Dear students, on the continuation of sampling test and in the sampling theory, I shall discuss today, that is on t-test and chi-square test. Here the population mean and sample mean we consider, and then in terms of the degrees of freedom, the t-test gives the values, that is in terms of numerical values, and here we go for taking a random sample like x1, x2, x3, up to xn from a normal population, and then we have to test the hypothesis that the mean of the sample is mu. Then we propose, for any given data, we propose some hypothesis according to the statement of the problem. Then we have two levels of significance. One is 5% level of significance and another one is 1% level of significance. That is contributed by student. He is a mathematician. He has invented the formula, that is t is equal to its absolute value, that is sample mean minus population mean divided by standard deviation, whole thing multiplied by square root of n. Here the population sample mean will be calculated for the given set of numerical values, and population mean will be given in the statement itself, or if it is not given, we have to assume based on the type of the data which is going to be discussed, and standard deviation which is to be obtained from the variance term in terms of the degrees of freedom. That is the usual formula what we take for arithmetic mean, sum of all the values of the variable divided by number of values, and standard deviation will be taken as that is sigma square root of 1 divided by n minus 1. That is, the general equation is here it is a square root sign we have to attach, because it should be whole to the power half otherwise. That is 1 divided by n minus 1. The usual formula goes sigma from 1 to n, that is xi, that is I is equal to 1 to n, xi minus x bar, where x bar is the actual mean of the given series, and whole divided by, in terms of, instead of n, in terms of n minus 1. That n minus 1 is nothing but degrees of freedom. What do you mean by degrees of freedom? Already in the previous discussion we have discussed about the degrees of freedom, and degrees of freedom is nothing but total number of observations minus 1. That means one number less from the total number of observations is the degrees of freedom, because it refers to the number of constraints appear in the from the given data. Now using this equation we decide two levels of significance. One is, as I told you, that one is 5% level of significance and the another one is 1% level of significance. Here we find the value of the probability in terms of the degrees of freedom, and we will compare the set of tabulated values of t distribution, and we have important conclusions like this. If the calculated value of t, this is what the theoretical meaning that we are going to conclude, if the calculated value of t is greater than the value of t from the table, that at 0.05, which refers to the 5% level of significance, then the difference between the actual mean and the population mean is said to be significant at 5% level of significance. And on the other hand, if the calculated value of t distribution, that is student t test, gives the value of it is greater than, that is 0.01, then the difference is said to be significant at 1% level of significance. If the calculated value of t is less than, that is 0.05, then the difference is said to be consistent with the hypothesis that mu is the mean of the population. That means mu and x bar. Remember, these two notations will play the major role directly with the basic statistics. As you studied like arithmetic mean, you can study that arithmetic mean x bar by taking the usual formula, but population mean the value will be given. For example, if there are section consisting of 60 students and some average population value is proposed as per the census data, where every year census will be collected, then if you take a sample from 60 students, for example like 10 students, 15 students, 5 students, like that, then you will find the actual mean from the sample you have selected from the population. That 60 refers to the value of population, that means total population, and a sample which you are going to draw from the total population is nothing but small n. That is, if you take it as small n is equal to 10, then you are going to calculate the arithmetic mean, the sum of all the 10 values divided by 10 you have to take, that is called as the actual mean, that we include in the t-test equation here. That is this one, x bar is the actual mean, mu is the population mean, and n is the number of observations, and sigma s is the standard deviation. Now I will take an example in order to prove this concept. It goes like this. You will find all the details sometimes will be given in the statement, and sometimes details will not be given. What type of details you need? The set of values or set of observations you need. From those set of observations, the actual mean you have to calculate, and then population mean, if it is given, you record it, and then you have to find the standard deviation in terms of degrees of freedom. Now the procedure goes like this. Here is an example. The 9 items of a sample have the following values: 45, 47, 50, 52, 48, 47, 49, 53 and 51. Does the mean of these differ significantly from the assumed mean of 47.5? What values you have to note from this given data? That means all these values 45, 47 up to 51 will represent the values of x. Then this 47.5 is the population mean. It is in general. This is only a sample which is given, and in general it is 47.5. Now the actual mean, because this 45 up to 51 is drawn from the total population. Now the sample population is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values are there. Then here value of n is equal to 9. Then go for the actual calculation from the arithmetic mean and standard deviation from this one. Let me record these values, and then I will just show how to calculate this t-distribution equation for such the values. That means it is only a simple reference. It is given in terms of the numerical values, these values, and this is going to be applicable for industrial problems, and their industrial problems like too many articles. For example, one machine produces in an industry, and then articles are to be tested. For example, thousands together articles are there. 1000 articles suppose a machine produces. Does not mean that all the 1000 articles which are produced by that particular machine will not be accepted of good quality. Then what we do here, some sample out of 1000 we take, and then we will test it. Then whether it is going to be accepted at 1% level of significance or 5% level of significance, like that. Now here is the one test that we are going to apply, and then we will see that what is the value of t, how it behaves with the table values, and then what is our conclusion that we are going to draw. Here it takes the values of x, that is 45, 47, 50, 50, 52, 48, 47, 49, 53, 51. These are the values. That is, x takes all these values, n is equal to 9. This is first to be documented. Then here I will calculate this one as arithmetic mean. We call it as actual mean, this one, actual mean or sample mean. Sample mean means 45 plus 47 plus so on plus 51 whole divided by, it is 9. So this value comes to be that is 49.1. What I did here, this is an equation I have taken like arbitrary number, that means we call it as arbitrary mean. Here this table shows all the values here, and then the arithmetic mean will be calculated by adding all these values. But what I do is, I go for shortcut method. I take any one number from these given values of x, But how to select that one number? You must remember that you have to identify which is minimum and which is maximum here from these given series of values. Normally we take normally we take the central value which shows the description from the lowest value to the highest value. That means in this series it starts from, probably it is 45, and then it goes up to 53. Then in between some value I choose. Maybe this describes some negative values and some positive values, and then it is easy to, that means to make the total numerical value as a smaller quantity. Then I will make it as d square, which helps me to calculate the standard deviation. Then arithmetic mean of the sample, that is arbitrary mean plus sum of all the deviations which were taken, that is d stands for, in this table, that is x minus a, that is called x minus 48, and then a plus, that means arbitrary mean plus sum of all the deviations which are measured with respect to the arbitrary number, and divided by small n, which gives the calculation as 49.1. Now what is the variance equation? Here this is one method, and variance, you know that sigma square, standard deviation whole square is nothing but variance. This is equal to, here you can take like sigma d square by 9 minus sigma d by 9 whole square. That means sigma d square divided by n minus sigma d divided by n whole square. What do you mean by d? D is equal to x minus a. This a stands for arbitrary mean. Now this one is called shortcut method. You know that there are three types of equations which we use. One is direct method, second one is shortcut method, and third one is step deviation method. But here step deviation method you can't apply, because that method is only applicable when the given values of x are equally divided. That means they have the equal difference. Whatever the difference you are going to take between first two values, and it should be uniform everywhere. That means h value you can separate it, and then you can apply the step deviation method. Now for this data, starting from, for example, like 45, it goes up to 53, the values are not equally distributed, so that they are unequal values, so step deviation method you can't apply. Then by shortcut method means in terms of d we write, but step deviation method in terms of u we write, that is x minus a by h. But here only the term we are writing. Every value which is taken as subtraction from each value of x, we call it as deviation of each value with reference to the arbitrary mean. That is coming to be calculation from the table, that is sigma d is this much and sigma d square is 66. Okay, we make use of these two values in the shortcut method equation to find the variance, and that gives 6.15, that value. Now that is variance we calculated, and standard deviation is 2.48, that is sigma is equal to root of 6.15, then it is 2.48. Then we take mu is the given population mean in the statement of the problem, that is 47.5. What do you require to apply this equation? That is t is equal to x bar minus mu, sample mean minus population mean divided by standard deviation, whole thing multiplied by square root of n. Now all the values are available. X bar is there, mu is there, n is there and standard deviation, that is 6.15. If you introduce all these values in the t-test equation, then you are getting that value as 1.83. Suppose you are getting this one as negative, because it is to be measured in terms of the absolute value, because it is in terms of the magnitude. Magnitude is to be taken in terms of the positive sense. Therefore, 1.83 with plus sign we refer. And now the degrees of freedom. Yes, your actual calculated value modulus of t is equal to x bar minus mu divided by, that is sigma of the sample, then whole thing multiplied by root n. This is coming out to be 1.83. This is the actual calculation by student t-test. Yes, 1.83. What is our discussion from this value, interpretation from this value? Yes, you are given totally 9 values, and the table gives, that means T distribution table. In every textbook it is given normal distribution, T distribution, chi-square distribution, values are given, and F distribution. All these values are given. So just like logarithm table, you can refer. Then here in terms of degrees of freedom means n is given 9, its df in t-test we take df is equal to n minus 1, that is 9 minus 1, 8. Against 8 you have to refer the t value, and it comes out to be 2.31, that is from the table value implies 2.31. Now actual calculation is 1.83 and table value gives 2.31, should be less than 2.31, that is table value. Then what is our conclusion? This implies that the value of t is significant at 5% level of significance. That means this value of t is at 0.05. Then the test provide evidence against the population, a mean being 47.5. That means that concept may be concluded in that way. Now we will go to the next example. A certain stimulus is administered to each of the 12 patients, give the increase in blood pressure as x takes the values, that is totally 12 values are given, increase in the blood pressure when some stimulus is administered to the patient. Can it be concluded that the stimulus will in general be accompanied by an increase in blood pressure? That means a doctor gives some stimulus which is given to the 12 patients, and the conclusion is what is the effect of this stimulus when it is injected to the patient. That is, we apply this t-test in order to give our conclusion whether that has the link between the stimulus and the increase in the blood pressure. As you know that there are two types of blood pressures, one is diastolic blood pressure and another one is systolic blood pressure. Now from this data again you have to consider in the same way, how many patients are there? Totally 12 patients. Yes, you take it as n equal to 12, and the population mean when it is not given you assume it as 0, because the highest number here and the lowest number, that number lies between negative values and positive values, and when it is not mentioned, that you have to consider as this is mu is equal to 0. Then sample mean you are going to calculate with the usual equation, that is the direct method we call it. Then simply add all the values, that is 5 plus 2 plus 8 minus 1 plus 3 0 minus 2 plus 1 minus 5 plus 5 plus 0 plus 4 plus 6 whole divided by 12, you are getting it as 2.583. This is the sample mean. Then standard deviation you are going to consider not by shortcut method, direct method, then it comes out to be 2.9571. Then what is the t-test equation that you are going to consider? T is equal to, once again, x bar minus mu and divided by standard deviation and whole thing multiplied by square root of n. When you consider these values to be substituted in the equation, then you will get it as 2.897, that is modulus of t, means absolute value for this 2.897. So, how many x values are given in this problem? Totally n equal to 12. What is your degrees of freedom in this equation? Degrees of freedom is 12 minus 1. That should be, that is table value at degrees of freedom 11 at 5% level of significance is 2.201. It is available in the table. What is our calculated value? That is 2.897, the actual calculation, but the table says 2.201, that is greater than this value. Therefore, when it is beyond the level of significance, that is at t is equal to, that means 5% level of significance, then it is obvious that the stimulus does not increase the blood pressure. That means there is no relationship between the stimulus which is administered to the patients which causes the increase in blood pressure of the particular patients. Therefore, that is by the t-test this much conclusion, but only it is at 5% level of significance. We talk about these two standard ranges, that is 1% and 5% level of significance. Then similarly, another different situation I am going to consider. Previous two discussions which I had, the statement of the problem, this is single series we have considered, first example, and the next example also we have taken, this is also single series, that means x takes single series. Now I will go for another situation, that is two series of observations we take, but still t-test how it behaves with this type of data. Here the data is very commonly known to discuss, like how to include these two series of values in making single series of observation, and then t-test can be applied. 11 students were given a test in one subject, they were given months further tuition, and a second test of equal difficulty was held at the end of it, right? And do the marks give evidence that students have benefited by extra coaching or not? Now, the data is like this, 11 students are there from 1 to 11, and the first test marks scored by, that means before giving the months further tuition, before giving it, the marks they have scored as 23, 20, 19, 21, 18, 20, 18, 17, 23, 16 and 19. This is the details before giving the extra coaching for 1 month. Now, after taking a second test with the same difficulty when it was conducted, and in place of 23, same student scores 24, second student scores 19, likewise the last student, 11th student, scores in place of 19 as 17. You can see the differences here, the first test and the second test. Maybe some conclusion you can draw from looking to these numericals which are scored for the representation of the marks, but how our formula t-test will go to give the conclusion by comparing level of significance. Now, what we do with this data, we make a single series by the given two series of observations by taking difference between two tests, that is first test and second test, otherwise second test minus first test. Then for that, let me take D, it is the difference, marks of first test minus marks of second test, that I am getting, and I will calculate whatever the value of D comes. That means here, for example, that is 23 minus 24 or 24 minus 23, in any way you can write. Similarly, 19 minus 20, otherwise 20 minus 19, up to the last number, that is 19 minus 17 or 17 minus 19. When you consider like this, then you will make it as the value of that D as a total, and it is going to be divided by the number of values, that is 11. Then ordinary equation gives arithmetic mean calculation, that is mean of D. D means difference, that is difference between first test marks and second test marks. Then you are getting it as 11 by 11, 11 by 11, that is 1. what is this d you are getting? Sum of all the values divided by n, that is sigma, this equation sigma of x, this x bar nothing but sigma of x divided by n. So n is 11 and sigma of x is also 11, then you are getting it as 1. The next calculation is variance. So variance means, once again I take in terms of the degrees of freedom. In previous case also we did like that. Then that is in place of x, here the new symbol I take it as difference once again, that is another form of x, because first one you take, for example this is marks the first test in terms of x1 series and second one is x2 series, and if you take the difference between x2 minus x1 or x1 minus x2 and you will name it as differences as d. Then after taking like that, you could have mentioned like x2 minus x1 as x3, otherwise x1 minus x2 as x3. In place of that I have taken it as d. Then d minus of arithmetic mean of d means your variance goes from each value you have to take the subtraction with the actually calculated, that is mean value, then divided by, that is whole square, divided by in terms of degrees of freedom. Then 11 minus 1 is 10, then that comes to be sum of the squares of the deviations is totally calculated as 50, then it is divided by 10 and you are getting it as 5. Then exactly what equation in terms of x you are writing for representing the standard deviation, this is written in terms of d, this one. I will just make the comparison because you are much familiar with the earlier symbol, that is x, and then but you have to become familiar with the another symbol, that is d. That means, what is the equation for standard deviation? Let me remind you about the basic equation of standard deviation. What is that basic equation? Standard deviation is equal to positive value, that is sigma x minus x bar whole square divided by n. Here I take in this case because there are two series of observations are there in the data, two series of observations are there, you have to make it as single series, then in place of x I will take it as d. Therefore sigma, it is d minus d bar, like that I take d minus d bar whole square divided by in terms of degrees of freedom, that is for the ordinary calculation this is in terms of df, this is not in terms of df. This is basic statistics, this is in the case of t-test, that is in sampling theory. Then for those values I denote it as d, then for that d I will use as variable minus of its mean, then it is taken as whole square, then it is divided by n minus 1 and it is calculated as 5. What is that? Variance. Now you are applying that variance is equal to 5. Then to get standard deviation means you have to apply 5, that comes to be 2.24, that is square root sign applied to the number 5. Then assuming that students have not been benefited by extra coaching. What do you mean by this? That means we propose the hypothesis for the given data when students were given extra coaching. Now I claim that assuming students have not been benefited by extra coaching, let me check from the t-test. It implies that the mean of the difference between the marks of the two tests is 0, because it is that value we will assume it as 0. Then by t-test it is sample mean minus population mean divided by standard deviation and whole thing multiplied by root of n. If you calculate in that way, we are getting it as 1.48, and table value for degrees of freedom, that is 11 is there, then 10 because one number less, then table value gives 2.228. Actually calculated t value is 1.48. If you compare these two, the calculated value 1.48 is less than this one at t 0.05, but mu is 0, then we conclude provides no evidence at 5% level of significance. So this is what the conclusion for two series of observation. I will go for another different situation now. A machinist is making engine parts with axle diameter of 0.7 inches. A random sample of 10 parts shows mean diameter as 0.742 and the standard deviation as 0.04 inches. On the basis of this sample, would you say that the work is inferior? Here you have to collect according to the given numerical values the symbols which are going to be used in t-test. That is, a machinist is making engine parts with actual diameter as 0.7. Then what exactly this 0.7? It is his target. Therefore, the means he is expecting 0.7 should be the diameter of that particular axle. That means how many axles he is going to prepare. He expects the diameter as 0.7 inches. I will take that 0.7 as the population mean. That means he is targeting all the axles diameter should be equal to each one should be equal to 0.7. Then how many? Then random sample of 10. That means total number of axles he has prepared may be more than 10. A sample is drawn from that total which he prepared, then we consider it as n is equal to 10, and for that population mean we assume as 0.7, then we calculate sample mean. It is also given there. What is the sample mean? That is, sample mean is equal to 0.742 and the standard deviation, it is also calculated value. So all the values here in this statement are calculated. If you compare with the previous problems, for example, here only x series is given and population mean is given, rest of the values you have calculated. Then in the next situation, here x series is given and population mean is not given. This is another type. And here in the next situation, more than one series is given, you made it as single series and then you applied t-test and you gave your conclusion. And in the next example, here all the calculated values are given. That means these four different situations which I would like to discuss. Now the next situation in this problem, all the calculated values are given. Only thing you have to assign proper symbol and then go for the application of t-test equation. That is, n equal to 10, population mean is 0.7, sample mean is 0.742 and standard deviation is 0.04. Then t is equal to sample mean minus population means divided by standard deviation multiplied by whole thing multiplied by root of n. Then it comes to be 3.16. Then total sample which he has drawn is 10. Then degrees of freedom should be 10 minus 1, that is at 9. Then 0.05 says 5% level of significance. Therefore, t is equal to 3.16 is greater than 2.262. What is your conclusion in this way if you get the answer? That means it is beyond the limitation of the table value. That means actually calculated is 3.16 and the table value for that particular degrees of freedom, that is 10 minus 1 is 9. At 5% level of significance is given in the table, that is 2.262, where calculated value is greater than that value, then obviously the hypothesis, that means our claim should be rejected. How the hence the worker is inferior. This is what the conclusion from t-test we are going to take. That means before going to conclude the application of t-test, what we have to do is what type of data is given and how this t-test behaves and for what purpose this t-test is to be the ending is to be interpreted. Now continuing in this way, another application concept we are going to use in sampling theory, that is chi-square test. This is another notation, chi-square test, which will be used same type of conclusion, but equation which is derived from chi-square is different. Here values which we collect from the given data as in terms of the frequencies, then we name them as observed frequencies, and we calculate another type of frequency using the validity of either binomial theorem or binomial distribution or Poisson distribution or normal distribution. So which one is suitable for the given type of data along with accepted observed frequencies, then you are going to calculate the expected frequencies. Then the equation says that is chi-square, looks like x square, but the symbol according to chi-square symbol, this is the equation, that is chi-square is equal to sigma y minus ei, otherwise O minus E whole square and divided by E, that's all. Observed frequencies minus expected frequencies whole square and divided by E. What we conclude with this, and what is the advantage from this chi-square test? Let me explain these things. That is, the value of the chi-square is used to test whether the deviations of the observed frequencies from the expected frequencies are significant or not. It will be also used to test how will a set of observations fit a given distribution. There in the previous situation when we applied t-test, arbitrary values were there, and those values were referred only to the values of the statistical variable x, but here we consider the number of observations in each input. In each input means against the statistical variable observations what we make, and we name them as frequencies. How will a set of observations fit a given distribution? What do you mean by set of observations? For example, in the basic statistics you have studied preparation of frequency table. What do you mean by that? Preparation of the frequency table? It is nothing but consisting of class interval, then number of observations, then you are going to take whether cumulative frequencies less than form and cumulative frequencies greater than form. Here it speaks about the application of chi-square, speaks about only the simple frequencies, because there are totally 5 types of frequencies. One is simple frequency, second one is cumulative frequency less than, third one is cumulative frequency greater than, next one is relative cumulative frequency less than, and fifth one is relative cumulative frequency greater than. Totally 5 types of frequencies are there. Now we are taking only the simple frequency. What do you mean by this? That is class interval, then number of observations, then it is CF less than, like that it goes. We need in each class interval, for example, students scored the marks between 0 to 10. For example, if I take like this, because your mark should be ended with 0 to 100 if it is a question paper consisting of 0 marks lowest and 100 marks highest. Okay, 0 to 10 in a section of some strength of the students, then how many students have scored between 0 to 10? For example, something like 3 students, then 10 to 20, like 12 students, like that it goes. Then what the observations you are going to make up to 90 to 100, in between it is distributed. You must get this total as 60 if it is the total strength of the section is 60. This I call it as capital N, otherwise it is called sigma F, means sum of the frequencies. What is chi-square test plays a role with reference to these values here? That means it will be used to test how the given observations are different from the expected observations. Given observations means from the problem data which you are going to collect, they are called as given observations. That means observed frequencies OI, otherwise simply O, that's all. different references will give you different type of notations, but the meaning is same. Then by which equation you are going to calculate new type of frequencies, we call them as expected frequencies. That is, expected frequencies means E only. Then O and E, what is the difference between these values? And it is to be concluded through chi-square test concept. Here also we discussed two limitations. One is at 5% level of significance and the other one is at 1% level of significance. What is another advantage? Chi-square provides a test of goodness of fit and may be used to examine the validity of some hypothesis about an observed frequency distribution. Now, for example, observations you made against each class interval now, and you are going to write application of binomial distribution, Poisson distribution and normal distribution. So, which one is more suitable in order to give the validity of goodness of fit? That means the values which you are going to calculate as expected frequencies from the given values of observed frequencies, which equation is best fit for by using this chi-square test. There are three theoretical distributions you have. What are those three theoretical distributions? We call them as probability distributions. First one is binomial distribution. This is the second advantage I have. Chi-square test provides a test of goodness of fit. It is for first case discussion binomial distribution, second case that is Poisson distribution, and third case normal distribution. Dear students, you know all these three equations and you have studied already earlier to this chapter. Okay. Now, let me give a reminder, that is binomial distribution. What is the equation for fitting the data? Here I use this word as fitting. What is the equation? That is capital N into Q plus P whole to the power N. What is this capital N? Capital N is equal to sum of all the frequencies. What is this frequency? That is N is equal to sigma, it is PR in terms of probability. In basic statistics we use this notation as F. This is number of observations, but in terms of probability, in place of F, this is called PR and it is called PDF bar PMF, means probability density function, or it is called probability mass function. Then this capital N will be multiplied and it will be applied. For example, N is total as 60 here, this is capital N, this is same, and probability, this P says success and this is says failure, probability of failure. When you fit this equation using this total and you are getting the distribution of all the values, fine. This is from binomial distribution. Now, Poisson distribution equation. So, Poisson distribution equation means PR, here this is also to be represented as PR multiplied by capital N, and here also N into PR is equal to capital N into e to the power minus m to the power r over r factorial. This Poisson distribution equation should be multiplied by the total frequency. This binomial distribution equation should be multiplied by the total frequency. Similarly, normal distribution equation, that is also PR multiplied by N, that is capital N, means sum of the frequencies 1 divided by sigma square root of 2 pi into e to the power minus z square divided by 2. This z you know already, it should be SNV, that means standard normal variate in the symmetric distribution. That means 0.5 probability value to the left side and 0.5 to the right side to make it as P plus Q is equal to 1. Therefore, z is equal to x minus x bar divided by sigma. Then this n, already I told you, it is sum of the frequencies. To verify the values which are distributed from this equation, the values which are distributed from Poisson distribution, and values explained from normal distribution, which data or which equation is more suitable and has the goodness of fit, then we test using this chi-square. That means some values will be given in the table, then we can use these equations according to the requirement. If it is Poisson required, then Poisson equation we are going to use. If it is given as binomial distribution, we will use that, and how that equation behaves with the help of this chi-square distribution, that is chi-square test. The equation is like this procedure, and it is also a goodness of fit, and it will give the relation between the theoretical meaning and the actual fact. Theoretical meaning is what? Theoretical meaning means given values, and the actual fact means what you are going to conclude with the chi-square distribution equation, that is sigma O minus E whole square divided by E. What you are going to conclude this value in terms of numerical value at 1% level of significance and 5% level of significance, and fitting of that data by which equation is going to be matching, then we will say that goodness of fit is going to be accepted or not. It has the relation, it will show the relation between the theoretical discussion and the actual fact. Actual fact means the values which we are going to actually calculate, and we name them as expected frequencies. Theory means that is called observed frequencies, and here this one actual fact means the values which we are going to calculate, new values as expected frequencies. Then here find the degrees of freedom and read the corresponding values, that is chi-square at prescribed significance level from the chi-square table. This is similar to t-test, already I told you that. That is you have to observe in the given data t at the bottom as suffix it is given. If it is given as 0.01, then you have to read it as 1% level of significance, like this type, t at 0.01 and t at 0.05. In one of the previous discussions, we earlier to this chapter I told you t at 0.01 is 1% level of significance and t at 0.05 is 5% level of significance. Then the comparison is required at which level of significance, according to that table value you have to collect, and then you have to compare for the given table of values, and you have to calculate the actual expected frequencies. Then how this equation behaves and how to use it. Here we can observe some points from chi-square test. From the chi-square table we can also find the probability p corresponding to the calculated values, and in terms of the given that is degrees of freedom. If the probability value is less than 0.05, the observed value of chi-square is significant at 5% level of significance. Similarly, if the calculated value of probability value is less than 0.01, the value of significance is at 1% level. Then if it is greater than 0.05, the calculated value, it is a good fit and value is not significant, like that. The combined interpretation we have to give. Then the commonly discussed type of situation is, you know about Mendelian genetics. In that Mendelian genetics, Mendelian has grown different types of garden pea seeds. In this garden pea seeds, you will find varieties round and yellow, wrinkled and yellow, round and green, wrinkled and green. How this is a very popular example, and it has been how this probability has been invented, and it is applied using the Bayesian criteria by Mendelian experiment in giving different types of garden pea seeds. What is the ratio in that one it is given? That is 9:3:3:1. This is a very important proportion which we have to follow according to this data. If there are any questions, then I'll answer.